Unit 12, Day 1, Graphing Linear Inequalities. Okay, so let's begin by filling out this box here. Important information about the boundary line. Okay, that's a word we're going to see. Okay, so shading. Greater than or equal to will shade above. Above. Where less than or equal to will shade below. So above and below. The greater than or less than sign means that the line will be dashed. Dashed. Greater than or equal to, less than or equal to will mean that the line will be solid. Okay, the last piece of crucial information we have, determining solutions. There are actually three ways for something to be a solution. Number one is that the point is in the shaded area. So the shaded area on the solid line which that is pretty important right there, the solid line, and or really three, so it's either in the shaded area, on the solid line, or makes the inequality true. Makes the inequality true. Okay, now for a bit of review, we just need to graph these three lines we're given. All right, so really nothing to it. Starting with our y-intercept, taking our slope, and there we have one of those. And connecting the dots. Not a real bright line, but a line nonetheless. Okay, number two, another bit of review. We'll start at -4. It's a -1/4, so it goes down over 4, up to the left 4. Okay. You take a straight edge, you'll get a nice, good line there. Okay, number 3, x equals 2. So with this we get the Vux part of Hoy-Vux. Vux. It's an x equals line, so it goes through 2. X equals 2. So we're going to get a vertical line that goes through those points right there. And there we have it. Okay, next term, what are the points? Solution of linear inequality. All right, so our third way to tell that is if this point makes the inequality true. So we have x and y. Now replace the x with 2 and the y with 2. 2 is less than or equal to -1/2 times 2 plus 1. Well, if we simplify this, we get, or if we just type this directly in our calculator, it'll tell us if it's true or false. But this becomes 0. 2 is less than or equal to 0. Yeah, that's false. That is false. So that is not a solution. All right, same thing we're going to do over here. If x is 1, y is 0. If we plug in 1 for x, so 1 is less than 2. That is true. So that is a solution. Okay, 6. X is 0, y is 1, so we'll plug in 1 over here. 1 is greater than x, so 0 minus 1. 1 is greater than negative 1. That is true. So that is a solution. Okay, now graphing an inequality, the way that this will work is we're just going to pretend that this is y equals x. Okay, honestly, just for the time being, we'll treat it like it's y equals x. Okay, so the slope is 1, y-intercept is 0. Okay, so I'm going to plot points here. Slope is 1. All right, I'm going to go, for the sake of it, put some points here. Okay. Now, we said before that at the very top, that greater than or equal to tells us we're going to shade above. Okay, so I'm going to shade above with a solid line. So we're going to have a solid line right here. Connects all these points. And we're going to shade above. So we are actually going to shade area above that. Okay, now is the point 3, 3 a solution? Well, if we go to 3, 3, it's that right there in red. Well, we have 3 ways to tell. 1, is it in the shaded area? Well, no, it's not. Okay. 2, is it on a solid line? Matter of fact, yes, it is on a solid line. So our answer is yes. Okay, and we can actually say that. We can say it's on the solid line. Okay. Same sort of thing we're going to do for number 8. Okay, this one is less than or equal to. So it is going to be below and solid. Below and solid. Okay. Okay, below and solid. So we're going to start with just the plain old line we've got. Negative 1/2 slope. Okay, so we know it's going to be a solid line. I'm going to shade below it. Okay. Now is 4 or negative 4, 4 a solution? So if I go, probably shouldn't shade it that dark. So negative 4, 4. Okay. Is it a solution? Well, yes. Why or why not? Well, it is in shaded area. As that was one of our criteria. In the shaded area, on the solid line, or makes the inequality true. That actually means we can actually use this, by the way. It's a nice way to do that when you don't have a graph. Okay. Last 2 here. Well, we have a less than sign, so that means we're going to shade below. When it all comes down to it. And it's going to be dashed. Okay, so taking these points, we'll start at negative 1, the y-intercept. Positive 2/3, up 2/3, up 2, and that'll run off. Down 2/3. Right, dashed line. I'm going to try to intentionally make that look like it has holes in it, because it does. It is a dashed line. Right, and we said we were going to shade below. So we'll shade below. Okay, so now our point, 3, negative 5. 3, negative 5. So first, is that in the shaded area? Yes. Okay, we don't have to ask any more questions. It's in the shaded area. So that's all we need to know. So it is a solution because it's in shaded area. Okay. 10, greater than sign right there. That tells us it is going to be above and dashed. So start off graphing like we would a normal line. Start at positive 3, negative 1 over 4, up 1 to the left 4. Okay, but this time it is dashed and above, so it'll be dashed and above. Okay. Now to check that point out, 0, 3. Okay. Well, first, is it in the shaded area? No. Is it on the solid line? No, it's on a dashed line. Okay, and then does it make the inequality true? Well, if we really wanted to check that one, I'll just go ahead and do that because it's a nice thing to check anyways. I haven't had to do that yet. So y is 3, so I get 3 is greater than negative 1/4 times x0 plus 3. Well, when I work that out, I end up getting 3 is greater than 3, which is false. So it is not a solution for any of those three. None of the three categories does it work. Okay, so I'm going to say it like this. It's not because it's on dashed line. Okay. Number 11, greater than or equal to, tells us it's going to be above and a solid line. So we'll graph this line. Well, y equals 2 that we're graphing. That's actually going to be the hoi part, our hoi vux. Okay, it's a y equals, so it's going to have a 0 slope, it's horizontal. So it's going to go through here. Now we said that it's going to be above and a solid line, so solid line, shade above. Now the point 2, negative 2. 2, negative 2. Okay, so 3 things to check. Is it in the shaded area? No. Is it on a solid line? No. And then almost certainly that doesn't make that inequality true because of those two. Okay, we can use the graph for this. So this is neither one of those. So it is not a solution. And I'm going to say not in the shaded area. Okay, now number 12, less than or equal to, that tells us it's going to be solid. The equal to portion of that tells us that. It's going to be solid, and it's going to be below. So if we were graphing this, y equals negative x, oh, there we go. Slope is negative 1. So it's going to start at negative 2, and it's a negative slope, so going down 1 over 1. Okay. Now this is going to be solid, so we need to connect these dots. Okay, and it's going to be below. So let's check out that point, 0, negative 2. 0, negative 2. Okay, so the 2 things we can check. Is it in the shaded area? No, it is not. Is it on the solid line? Yes. Okay, so this is, in fact, a solution here because it is on a solid line. Okay, a few more like this one. All right, so here this one is going to be below, and it's going to be dashed as well. So we'll graph that. Let's see, slope of 1. So we'll start down there. Dashed. Okay. Yeah, I'm intentionally leaving holes in that. That's below that line, so it's in this area over here with a dashed line. So the point 4, -5, is it in the shaded area? Yes, actually we don't have to check the other. So it is in the shaded area, and so it's a solution because it is in the shaded area. That's all there's that one. Okay, 14. This is an X line. Okay, so this is where we might refer to y of x. We have an x equals, so it's going to be a vertical line, undefined slope. Right, so when we graph this, we'll know what that is. Now, let's see, x is greater than 3, so that will be this line starting right there. But it's a vertical line, so we're going to have points going this way. Okay, now greater than tells me it's going to be a dashed line. So draw a dashed line with holes in it. All right, now we run into a problem here, greater than. Well, since we're talking about the x direction, greater than actually means to the right. That's where the numbers that are where the x is greater than that. So this one is actually, in this case, it's actually shading to the right. So that point -2, 0, -2, 0. Okay, is it in the shaded area? No. Is it on a solid line? No. Now we could ask, is this a solution to that inequality right there? Well, if we took the x and the y, we plug that in right there. So, well, x goes right there, so that would be -2 is greater than 3. Well, if you type that in your calculator, you get a big fat false. So it is not a solution, which also tells you why we didn't shade this side of the line. Okay, this side is not, these are not solutions, so those are. So it'll help us figure that out. So it's not, I'm just going to go ahead and say that it's not in the shaded area. Since that is pretty obvious from our graph. Okay. Last 3 here. All right, so we want to, here it says write an inequality to represent each graph. Okay, so we need to figure out the slope, the y-intercept, the b. Okay, the y-intercept for that. We also need to figure out, in order to figure out the inequality, and then we need the sign. So we know it's going to be something like y is something, mx plus b. All right, so the slope here, let's see, we've actually got some points given to us. Let's use those. The rise is, it's up there at 5, so 1, 2, 3, 4. It's going up by 4 and over 1. So the slope is 4 over 1, or just 4. The y-intercept right up there looks like it's at 5. So we're going to have 4x plus 5. Now, is this going to be a less than or equal to, greater than or equal to? Well, it's below this line, so it's going to be a less than. It's a dashed line, so we're not going to have an equal to right there. So y is less than 4x plus 5. Okay. All right, we're going to do the same sort of thing with this one right here. This, first off, it's shaded above. It's shaded above. So that tells us it's going to be a greater than. Solid or dashed? Solid. So we get an equal to bar right there. Now just need to figure out the slope and the y-intercept. Now the y-intercept, these points are not exact, kind of going over here. We're going to actually go that these are at 6, 4, 2, and 0. Okay. So our slope, it looks like it's actually going down 2 and over 1. So negative 2 over 1 or just negative 2. Y-intercept is up there at 6. So the b is 6. So we get y is greater than or equal to negative 2x plus 6. Okay. All right. Now 17, there are two ways to look at this that I can just kind of see right off the bat. One is you could actually graph this. Well, we don't have a graph, a grid to do. But what I would probably do is something to this effect. Negative x plus 3 would be, so that's 3, and negative slope. So it would go down 1 over 1, down 1 over 1, down 1 over 1. And it would look something like that, except that it would be dashed. And this would shade above. Okay, so I'd try to take these points here, 0, 3. So here's a 0, 3. Well, that we want to know which one is a solution. So that's on the shaded, that's on a dashed line, so that one's out. The next one, 1, 4. That will be right about here. There's B. Okay, that's in the shaded area. So that is shaded. I'm going to hold on to that one. Negative 1, 4. Well, negative 1, 4 would actually be on the dashed line, so that one's out too. 0, negative 3 is way down here. And so it wouldn't be in the shaded area. So that one is out too. So it does end up being B. But let me show you how to do this algebraically. If I plugged these things in, let me grab the, okay, if I plugged these points in, so these are all x's and these are all y's, right? If I plug these in here, I want to know which one's a solution, which one makes that inequality true. So just for this one right here, I'm going to do this. So I'm going to do y is greater than negative x plus 3. So if I replace the y and the x with x is 1, y is 4 respectively, I get 4 is greater than 2, which is true. So this is the only one that actually makes the inequality true. So those are kind of the two ways to look at this one. All right, so let's get working.